Shop, the future's calling. Maths and mind colliding. Daily dose of power. AI's here. See ya.
Today, let's learn the new ways. Guys, welcome to another lesson of the Daily Dose of Mathematics. Today, we're going to be doing question 8.
Yeah, it's question 8.
From the Limpopo June 2026 question paper. No?
Yeah.
It has to do with optimization. We're going to be putting the solution in the senior marker. And then we have a song that emphasizes optimization. Let's take it through it too.
Since we're dealing with question 8, it says, just after birth, the weight of a baby drops for a few days and then starts to increase again. The average weight of a baby in its first 30 days of the life cycle can be approximated by the following equation.
So we're given a formula. No?
Yeah.
We say, what's the formula? Yeah,
M of t is equal to
M of t. So guys, in this optimization question, these are the simplest. If you are given an equation and then we're supposed to use that equation to determine whatever it is that you're asking you should make sure that you are not afraid of this one. So if M of t
is equal to 0.02
is
t
0.02
t cubed,
okay,
minus 0.2 t squared,
minus 0.2 t squared,
plus 3200,
plus 3200. Okay.
By which our time is greater or equal to 0, but it cannot be, it's less than 30, less or equal to 30.
So you are given a restriction that your time in days, no?
Yeah,
is going to be greater or equals to 0, no?
Yeah,
but it should be less than 30. No?
Yeah,
so we're going to be looking at this for the whole month, more or less. No?
Yeah.
Okay. Now, what else do they say there?
They say where t is time in days and m of t is the weight in grams.
Okay, so we have our mass in grams. So whatever answer that we're going to get in mass is going to be in grams. No?
Yeah.
What else? And then they say t is going to be in days.
Yeah.
Okay, we can go to the first question. Now, guys, such questions, it needs you to know a little bit of English, but we need to know something about synonyms. We also need to know something about maximum, minimum. Those are the words that we are going to be talking about in this particular question. Okay, let's go. Let's check. What is 8.1?
8.1 says you should calculate the weight of the baby at birth.
So we should calculate the weight of the baby at what? At
birth.
Initially.
Yeah.
Now, these are the ways that we're going to be looking for, guys. Initially, at the beginning. So here at birth, it's initially, we're going to tell them with t is 0. No?
Yeah.
And then it means which we're going to tell them with m of 0. Instead of m of t, we're going to say m of 0.
M of 0 is equal to 0.02 open bracket 0 all cubed, minus 0.2 open bracket 0 all squared plus 3200.
3200. Okay. Now, as you can see, everything that has the t is going to disappear because any number multiplied by 0 is 0. Ne?
Yeah.
So what is our final answer here, Itu?
M of 0 is 3200.
It's 3200. And then because it's a mass, we're going to write it in grams. Ne?
Yeah.
Yeah, because this one is only 1 mark, we're not going to put it in the serial marker, this one. Ne? So we're going to leave it like this. Okay. Let's go to the next one. It's 8.2. Ne?
Yeah. 8.2 says calculate on what date the weight reaches a minimum.
Yeah, this is the way that we're talking about. It's minimum. So here, guys, if you can check what kind of a function is this one that they gave us, because they can give us different functions. They can give us parabolic function or a cubic function. What kind of a function is this one?
It's a cubic function.
It's a cubic function. Now, if you look at the cubic function, you can just draw a rough sketch. The cubic function has a maximum and a minimum. Okay?
Yeah.
So it means when they talk about minimum or maximum, we know with at maximum, the gradient is 0.
Yeah.
We also know with at minimum, the gradient is what is? It's 0.
It's 0.
So for us to be able to do this question, we're going to start by telling them with MT,
yeah,
which is the formula that they gave us. No?
Yeah.
It's going to be given by 0.02. No?
M of t is equal to 0.02 t cubed,
okay,
minus 0.2 t squared plus 3200.
Plus 3200. Okay, sure. Now, with that being said, we're going to tell them for minimum, again.
Yeah.
Or we can say at minimum. At mini.
Mean.
Yeah, we're going to tell them with m prime of t.
M prime of t
is equal to 0.
Is equal to 0.
Okay, and then from the onwards, we're going to differentiate.
Okay.
So we're going to have
m prime of t.
M prime of t, yeah. What do you get?
which is equal to 3 multiplied by 0.02 is 3 all over 50.
Okay, as a decimal, what do you get as a decimal?
As a decimal is 0.06.
It's 0.06.
Let me confirm it in a calculator. I just did it in the mind thing.
Okay.
0.02
multiplied by
3
yeah
is 0.06.
Okay, 0.06. Let's write it like that. Let's say it's 0.06 t. 0.06 t squared.
T squared.
Okay, yeah. And then we have the other one, we have 2 multiplied by 0.2. Should give you 0.4 based on what you just said.
Yeah, should give me 0.4.
So it's minus 0.4
yeah.
t.
Yeah, it's minus 0.4 t.
Okay, the other one, it's a constant.
Yeah.
It disappears.
So then we're going to have 0.06 t squared minus 0.4
yeah.
t.
Okay.
So from here we know, or just because we said m of t is equal to 0, we're going to have 0, which is equal to 0.06 t squared.
0.06 t, okay, squared.
Minus 0.4 t.
0.4 t, yeah?
Yeah.
Okay, sharp. Then we can clearly see there's something common between these two things. No?
Yeah.
Again, now we can't deal with decimals, right?
Yeah.
But we can see which there's a variable which is common. So we're going to leave the numerical values like that, the decimals like that, but we're just going to take out t as a common factor.
Okay.
If you take out t as a common factor, you are left with what on the first one?
Left is 0.06 t.
0.06 t, no?
Minus 0.4.
Minus 0.4. Okay, sharp.
Close bracket.
Close bracket. And then now we can then conclude here. We see the first t can either be using the zero factor log.
Yeah.
So I'm going to tell them t
is equal to 0
or
0.06 t
is equal to
0.4.
Taking the 0.4 to the other side.
Yeah.
Okay, let's divide both sides by 0.06.
Dividing both sides by 0.06, by which t is going to be equal to, let me punch it in the calculator.
Yeah. Yeah, guys, if you have your calculator, then you just put the fraction thing in. If you are afraid of working with decimals, decimals would get them in earlier grades. So from here, we're just going to put it in the calculator. Because your calculator can handle the decimals with ease. No?
Yeah.
So it's 0.4 divided by 0.06.
0.4 divided by 0.06.
It should give us something like.
So the answer is 20 all over 3, by which is 6.67.
All over 3, no?
Yeah.
Which is equivalent to
6.67.
6.67. Okay. Approximately 6.67 days. No?
Yeah.
Okay. So now remember, they said we want to get the minimum. No?
Yeah.
Now we know which 0 gave us 3,200. Okay?
Yeah.
But we don't know whether it's minimum or maximum. Okay?
Yeah.
And then if you check here, we got another one, another time. So we're going to try to check does this one give us the minimum or the maximum? If we get something bigger than the 3,200, it means this one is going to be the maximum, the one that we just got now. Okay?
Yeah.
So we're going to take it there. We're going to tell them which we have m. We're going to take it to the original equation.
Yeah.
M of t. Okay?
M of t.
Yeah, but instead of t now, we're going to write 20 all over 3. Yeah?
Which, okay. So we write the 6.67.
No, let's not write it as 0.67 because that one, we are the ones who round it off again.
Okay.
Remember, we are going to round off the final answer. Yeah? So when we get to the final answer, that's when we're going to round off. That's why I'm saying let's just put it as a fraction here and say 20 all over 3. Yeah, 20 all over 3. Okay. And then you have 0.02.
Yeah. 20 all over 3.
Yeah.
Is equal to 0. Okay, 0.
It's m of, yeah, 20 over 3. Yeah.
0.02 open bracket.
Yeah, open bracket.
20 all over 3.
All over 3.
To the power of 3.
To the power of 3, yeah.
Minus 0.2.
0.2, yeah.
Open bracket. 20 all over 3.
Over 3.
Plus 3,200.
Squared. You forgot the square.
Oh, squared.
So it's supposed to be 0.2 multiplied by
0.02 open bracket to the power 20 all over 3 close bracket cube.
Squared, yeah. The first one is cubed. Okay?
The first one is cubed.
Yeah, the second one is squared.
Minus 0.2 open bracket 20 all over 3 close bracket squared.
Yeah.
Plus 3,200.
Yeah, plus 3,200. Okay, yeah, we get.
By which m of 20 all over 3 Let's punch it on the calculator.
Yeah.
We'll try to be heroes. So on the calculator, we're gonna have
0,0.
0,02,
Yeah.
open bracket, a fraction of 20
all over 3.
all over 3.
Yeah.
20 all over 3. Then we're gonna close our bracket.
Yeah.
Outside, we're gonna have to the power of 3.
Yeah.
To the power 3
Yeah.
minus 0,2.
Sure.
Open bracket,
Sharp.
a fraction
Yeah.
of 20
all over 3.
all over 3,
Squared.
close bracket,
Yeah.
squared,
Yeah.
plus 3,200.
Okay.
By which our answer is 31,097,037.
So it's 3,001.
3197.
97. So it's 3,197 again.
Yeah, it's 037.
037.
By which is 04. Can make it 04.
Okay, so we can tell them which for me now we are sure now,
yeah.
Which is the minimum one. Okay, good. I agree they were asking us what was the question. Let's go back to the question again.
The question says calculate on what day the weight reaches a minimum.
Yeah, so on day 0, it's 6,67.
Okay.
On day 0,6. Therefore, you will tell them which therefore the mean was reached on
6. On day 6,67.
Yeah.
The mean was
reached.
The mean was reached. The mean was reached.
Yeah, like you're just supposed to say, I from here onwards, I'm sure you just show them what this one gives us the minimum. It doesn't give us something bigger than 3,200.
Yeah.
So from that onwards, we can make a conclusion which, okay, therefore, on day 6,67,
yeah,
it's when the mean was reached.
Okay, so then therefore,
on
T mean,
yeah,
T mean is equal to 6,67 days.
Yeah, you can also tell them something like this. You can say because just my says we're just trying to make sure that we don't lose any marks. But tell them with m of 0 is greater than m of 6,67.
Okay.
So it means this one is a minimum, the other one is a maximum.
Yeah.
We are trying to just make sure that we cover all these sides. Okay, let's play the song before you screenshot. Okay, you're screenshotting. Okay.
Okay, then we can play the song.
Yeah, play the song, and then we're going to take this to the senior marker, guys, and then so that we can see, did we make any right notations? We're trying to make sure that you don't make mistakes that teachers are making here. So we're trying to make sure that we also put some guardrails on our working. Okay.
Welcome to the daily dose of mathematics. Daily dose. Optimization questions. Don't let them trick your mind. Trick your mind. All big. It's not just volume. Any formula you can find. Any formula you can find.
Marking breakdown.
Surface area, perimeter, or profit
0,
on the
O2t cubed 0, 2t squared plus 3,200. Status: correct. Mark awarded. 1M. Method: identifying or using the correct function, derivative concept, at min m t equals 0. Status: correct. Mark awarded. 1A. Accuracy: setting derivative equal to 0 for minimum. m t equals 0, 06t squared 0, 4t. Status: correct. Mark awarded. 1A. Accuracy: correct differentiation. Solving 0 equals 0, 06t squared 0, 4t, implies t equals 0 or t equals, frac, 23, 6, 67 days. Status: partially correct, missing justification, selection between the two critical values. Mark awarded. 1ca. Consistent accuracy, correct roots from the derivative, but missing a test or explanation for why t equals, frac, 23, is chosen over t equals 0 as the minimum. 2. Corrective feedback. Error location. After finding the critical values, t equals 0 and t equals, frac, 23, you jumped straight to concluding the minimum is at t equals 6, 67 days without formally testing or rejecting t equals 0. Logical flaw. A derivative equal to 0 only identifies turning points, local maximums or minimums, or stationary points of inflection. Since a cubic function has both a local maximum and a local minimum, you must explicitly prove which value represents the minimum, either by substituting back into the original equation to compare values, using a second derivative test m, t, or using a number line, sign chart. Socratic question. How can you use the second derivative test, m, t, or compare the function values m, 0, and m, frac, 23, to mathematically prove which critical value corresponds to the minimum weight? 3. Caps and formal notation compliance. Formal terminology. Your written explanation at the end, on day 6, 67 the min was reached, is a bit informal. In CAPS exams, it is best to state conclusions cleanly using mathematical symbols, e.g., minimum weight is reached at t equals 6, 67 days. Differentiation notation. You correctly applied standard power rules for polynomials. 4. Coach's summary. What you did well. Your differentiation of the cubic function and your algebraic manipulation to solve for the critical values were executed cleanly and accurately. Area for improvement. Always remember to justify your selection when multiple critical values are found, ensuring you conclusively prove whether a point is a maximum or a minimum to secure full exam marks.
Okay, I don't know what Itu did, guys, but I remember telling Itu to say, let's check, guys, which between the two. They're supposed to compare. You didn't put that thing there.
Or the T0 is equaling to, or the T0 is equaling to 3200. I didn't write it here. It was written at the first thing.
First step, okay. Yeah, we're supposed to compare because as I was telling you, between the two of them, we don't know which one is maximum, which one is minimum. Okay, now with that being said, guys, we're going to move on to the next question.
Yeah.
Yeah, remember, guys, we have this prompt. If you want it, just request prompt. This prompt assisting you when you're practicing alone because you think you're doing the right thing, only to find that when you go to the examination, when the results come, Jen, and then you check your statement there, it's saying something totally different because when you thought you were doing the right thing, but at the marking center, they have a certain way in which they mark. No?
Yeah.
So we need to be careful of notations. We need to be careful of the formal notations that they use them. Okay. 8.3. No?
Yes.
What is 8.3?
On 8.3, they say calculate the maximum weight of the baby in the 30-day period. Okay,
now this one here, guys, it's a maximum weight.
Yeah.
Now, max, basically, if you see the weight maximum, like minimum, maximum, it's associated with the differentiation.
Yeah.
Now, we already know between the two things that we got,
okay,
we got M0, which it's we can start then.
M0.
M0. For M0, we got
3200.
But 3200, the one. So basically, it seems as if this one is our maximum.
Yeah.
And then it doesn't make sense. Why would they ask us a question that we got on 8.1? Because we already got this thing here. And then we know which we got a minimum, okay, which is M of 6,67, right?
Yeah.
And then that one we got what?
We got S31. 3197,04.
Okay. Now, the problem with this thing here is that because now they gave us a restriction. Like they were saying, you are supposed to work from here. So they gave us a starting point and an end point.
Yeah.
So we need to check which from the starting point. Starting point is 0. It's fine. We know what is there.
Yeah.
And then we also checked which this thing here is going to go to a minimum somewhere there after 6 something.
Yeah.
After 6 days. Now we are going to check at the end here. Does it pass our maximum? We're not going to assume what this thing here is going to be stopping there at our maximum.
Yeah.
So in other words, we're going to check something which we don't usually do. We're going to check for M of 30.
M of 30.
Yeah.
I'm going to substitute it on the...
Yeah, I'm going to substitute it on the original equation.
Okay, we're going to have...
M of 30, so we have
0,02.
Yeah.
Open bracket. 30 squared. 30 cubed, I mean.
30 all cubed, yeah.
Minus 0,2.
Minus 0,2.
Open bracket. 30 all squared.
30 all squared.
Plus 3200.
Plus 3200, okay. Just type this in your calculator, then you do.
Let's put it in our calculator, by which we're gonna have 0.02 open bracket 30 first bracket cubed minus 0.2 open bracket 30 all squared. Oh, I was doing a mistake. Sorry about that. 12 power of 3 minus 0.2 open bracket 30 all squared plus 3,200.
It wants to be American, guys. Calls the numbers like Americans.
Okay, so then our answer is, our M of 30 is
500.
is
What?
3,560.
Is 3,560.
60. 3,560.
Comma.
No comma.
Oh, no comma. Yeah, so our maximum. So it means this thing here, it passed our, because of the starting point and the end point.
Yeah.
After day 30, then it means our max, we're going to tell them which is going to be 3,560.
Okay.
So we are going to play the song. Okay, you started by cutting. Okay,
Let us play our song.
Yeah.
Page on the page, on the page. Read the question carefully. Step onto the stage. Step onto the stage. Step 1, build the formula with variables in store. Substitute and simplify. Just one left to explore. One left to explore. Yeah, bo. Make it one variable, don't leave it in a mess. Then you take the derivative, make the power rule drop. Set it equal to 0, so the curve begins to stop. Solve for x, find the value, check if it makes sense. Hey bo, no negative dimensions. Keep your logic intense.
1. Marking breakdown.
If they ask for
Identifying
maximum,
boundary values,
find
critical
the
points to test. T equals 0, T equals frac 23, and endpoints like T equals 30. Status. Correct concept. Testing boundaries and local turning points for an absolute maximum in a closed interval. Mark awarded. 1M. Method. Evaluating the function at relevant domain endpoints, critical values. M. 30 equals 0. O2, 30. Cubed 0, 2, 30. Caret 2 plus 3,200 equals 3,560. Status. Correct substitution and arithmetic evaluation. Mark awarded. 1A. Accuracy. Correct maximum value determined. 2. Corrective feedback. Error location. Your working and final answer are completely correct. You correctly recognized that when finding the maximum weight over a closed interval, t, in 0, 30, you must test the boundaries of the interval in addition to the turning points. Logical flow. Comparing m, 0, equals 3,200, m, 6, 67, approximately 3,197, 04, and m, 30, equals 3,560 clearly proves that the absolute maximum occurs at the endpoint t equals 30. Socratic question. Since you have all the evaluated values, 3,200, 3,197, 04, and 3,560, how would you write a definitive concluding statement to secure full marks for your final answer? 3. Caps and formal notation compliance. Formal terminology. Make sure to clearly state your final comparison or conclusion. E.g., maximum weight equals 3,560 when t equals 30. Closed interval rules. In caps optimization problems involving a restricted domain, like a 30-day period, always check the boundary values, t equals 0 and the upper limit t equals 30, alongside any local extrema. You executed this rule perfectly here. 4. Coach's summary. What you did well. You correctly identified that optimization over a given period requires checking the endpoints of the domain rather than just relying on the local turning point. Area for improvement. Ensure you always write a clear, explicit final conclusion statement linking the maximum value to its specific time, t equals 30 days, to leave no room for ambiguity for the external examiner.
See a bonga for pulling through the lesson. Hope you caught that daily dose of magic. Like the video and leave us your